This lecture video goes right along with your Chapter 7, Section 3 lecture notes. We will begin adding and subtracting rational expressions. In this section, we will focus on rational expressions that already have the same denominator. Consider that if we have two fractions with the same denominator, such as 2 over 3 plus 5 over 3, we can simply add the numerators. We have 2/3 plus 5/3 for a total of 7/3. The same thing is true with rational expressions. If they have the same denominator, we can simply add the numerators. Take a look at this example. Notice that the denominator in both expressions is x squared plus 11x plus 24. This means that we can simply add the numerators of these two expressions. So we have x squared minus 3x minus 51 plus 6x plus 11, all divided by x squared plus 11x plus 24. Simplifying in the numerator and combining like terms, we have x squared minus 3x plus 6x, or plus 3x. We also have a minus 51 and plus 11, which combine to become minus 40. Now that we've added these two expressions together, we need to use our methods from our previous sections to simplify. We begin by factoring the numerator and denominator. X squared plus 3x minus 40 can be factored as x plus 8 times x minus 5. And x squared plus 11x plus 24 can be factored as x plus 8 times x plus 3. Now we look for common factors in the numerator and denominator, and we notice that there's a factor of x plus 8 in both the numerator and in the denominator. This leaves us with simply x minus 5 in the numerator and x plus 3 in the denominator. Let's take a look at another example. In example 2, we are again adding two rational expressions, and they already have a common denominator. That means we can combine them by simply adding the numerators. That's x squared minus 9x plus 5 plus 2x plus 7 in the numerator and 16 minus x squared in the denominator. Combining like terms in the numerator, we have x squared minus 7x plus 12. Now let's factor the numerator and the denominator to look for common factors that may simplify. X squared minus 7x plus 12 can be factored as x minus 3 times x minus 4. 16 minus x squared is the difference of squares, so that can be factored as 4 plus x times 4 minus x. Notice that we have a pair of opposites. We have x minus 4 in the numerator and 4 minus x in the denominator. And since we could rewrite 4 minus x as negative 1 times x minus 4, we can cancel out the x minus 4 and 4 minus x, but it leaves behind a factor of negative 1. So the sum of these two rational expressions is negative x minus 3 divided by 4 plus x. Take a moment to notice that if we were to distribute the negative to both terms in the numerator, this expression is equivalent to the expression of 3 minus x divided by 4 plus x. Let's go on to example 3. In example 3, we are going to switch from adding two rational expressions together to subtracting. Now we have 10 over 3x plus 21 minus 4 over 3x plus 21. And just like with addition, as long as we have the same denominator, we can simply subtract the numerators. So this becomes 10 minus 4 divided by 3x plus 21. Since 10 minus 4 is 6, we have 6 over 3x plus 21. Now let's see if we can factor the denominator. 3x and 21 have a greatest common factor of 3, and factoring out a 3 leaves behind a factor of x plus 7. And since 3 goes into 6 two times, we can simplify 6 over 3 as 2 over 1. Now we have as the difference of these two rational expressions 2 over x plus 7. Let's take a look at example 4. In example 4, we are again subtracting two rational expressions that already have the same denominator. A word of caution, make sure that when there's multiple terms in the numerator being subtracted, that you distribute the minus sign to each term in that numerator. Your best bet is to use parentheses. Subtracting in the numerator, we have 3x squared plus 5x minus 33 minus the polynomial 2x squared plus 8x minus 23. And the denominator is simply x squared minus 9x plus 20. Simplifying in the numerator, we first need to distribute the negative sign to each term inside the parentheses. This becomes 3x squared plus 5x minus 33 minus 2x squared minus 8x plus 23. Combining like terms, we have a 3x squared and a negative 2x squared, which combine for a total of 1x squared. We have a positive 5x and a negative 8x for a total of negative 3x. And we have a negative 33 and a positive 23, which have a total of negative 10. Now that we've simplified the numerator completely, we will factor the numerator and the denominator and look for common factors. X squared minus 3x minus 10 can be factored as x minus 5 times x plus 2. And x squared minus 9x plus 20 can be factored as x minus 5 times x minus 4. Since the numerator and the denominator each have a factor of x minus 5, this expression simplifies to x plus 2 divided by x minus 4. Let's go on to our last example. Take a look at the two expressions in example 5. Notice that in the denominators we have pairs of opposites. We have an x squared minus 49 and a 49 minus x squared. In the second one, we have x squared minus 16 and 16 minus x squared. Remember that we can rewrite opposites so that they look alike with a factor of negative 1. That is, we could rewrite 49 minus x squared as negative 1 times x squared minus 49. So now this becomes x squared plus 10x minus 16 over x squared minus 49 minus 2x minus 23 over x squared minus 49. And now that we have matching denominators, we can combine the numerators. We have x squared plus 10x minus 16 minus 2x plus 23, being very careful to distribute the negative to each term in the numerator, and our common denominator of x squared minus 49. Combining like terms in the numerator, we have x squared plus 8x plus 7. And factoring, we have x plus 7 times x plus 1 in the numerator, and with x squared minus 49 being a difference of squares, we have x plus 7 times x minus 7 in the denominator. And with a factor of x plus 7 in both the numerator and in the denominator, we simply have x plus 1 in the numerator and x minus 7 in the denominator. Let's apply the same process to the second expression. We again have opposites as our denominators. So we'll consider that 16 minus x squared could be rewritten as negative 1 times x squared minus 16. And multiplying the second term of this expression by negative 1, we have x squared minus 2x minus 11 over x squared minus 16 plus 7x minus 25 over x squared minus 16. And now that we have a common denominator, we can combine the numerators. We have x squared minus 2x minus 11 plus 7x minus 25, and our common denominator of x squared minus 16. Combining like terms, we have x squared plus 5x minus 36 over x squared minus 16. The numerator can be factored as x plus 9 times x minus 4. And being the difference of squares, the denominator factors as x plus 4 times x minus 4. And simplifying, we are left with x plus 9 divided by x plus 4. And that will conclude this lecture video on adding and subtracting rational expressions that already have the same denominator.